Can you see my screen?
Yes.
Okay. Hi everyone. My name is Sherif Abdelhamid, and this work was done in collaboration with James Bangura, James Jivers, and Mona Ali. And in this work, we are introducing CryptoLearn. It's a web-based online educational platform designed to introduce students to cryptography, quantum computing, and post-quantum cryptography through interactive and game-based learning. So, in this work, we focus on making advanced cybersecurity topics accessible, easy to understand, especially for young age like middle school and high school students, and also for undergraduate students. We use visual explanation, hands-on exercises, and narrative-driven activities. Um, as you know that cryptography is central to cybersecurity and digital infrastructure. The problem is most students only encounter these topics late in undergraduate programs. And this delay creates like barriers because cryptography concepts often rely on mathematical foundations that students haven't yet developed. And there is therefore a strong need for educational tools that introduce these concepts earlier, like high school or middle school age, and using accessible explanation and interactive environment. The goal of CryptoLearn, our platform, is to provide engaging digital learning environment where students can explore cryptographic ideas through activities instead of focusing purely on just a mathematical foundation or theory. And the platform focus on conceptual understanding and exploration. It has also game-based elements, and it supports scalability and extensibility, which means in the future, new learning sessions or modules can be added without having to make a lot of changes to the platform itself. The platform combines several instructional approaches, as I mentioned, tutorials, graphical explanations, puzzle-based learning, um, and the students apply what they're learning through exercise and games. And these are some of the lessons we have, like substitution ciphers, how to hack a Caesar cipher, some popular math puzzles in cryptography, historical ciphers, and then we move to a little bit more advanced encryption techniques like polyalphabetic. And then we move from symmetric to asymmetric encryption, and then talk to our students about what is public key encryption and how it is different from single key encryption. So this is on our web page, and behind the scenes, we have a really sophisticated architecture. It's a multi-tier architecture, consists of three layers. A presentation layer, which has a user interface. This is where me or instructors and the students interact with the system. It has also visualizations, exercises, animation. The application logic layer it defines the logic of the application, the games, and how the students can navigate the platform. And the back-end layer, it store information about the students, about the games, their progress, different exercises, and the lessons. Um, we were consistent in each learning module design. So it was very important for us. So each module follows the same pattern. So students become familiar with the structure and can focus on understanding the concepts. And each module contain first concept explanation. It has at least one or two illustrations, visual, some interactive activity to support learning, and it has sometimes immediate, it has like quizzes or questions with immediate feedback. And this is how we progress through from basic ciphers to quantum computing and then post-quantum cryptography. So this is like an example of one of the modules, especially the Caesar ciphers. This is one of the first modules. And here, a basic concept of Caesar cipher, how it works. It has some animations here. Students can provide the input plain text message, and then it will generate the cipher text. Students can shift the letters in a different ways and see immediately how the cipher text will change. And this is another activity. Here also, students can put the encrypted message and then they click on Analyze Frequency, and it will tell the students which letters are more frequent. And this is one of the ways for the students that they can break the Caesar cipher or the encryption in general uh, based on the frequency of the letters. Like, for example, in English, we know that E is one of the most frequent letters. So, for example, here, if we see H very frequent, then here the student might guess that H is corresponding letter to E in the encryption. So before we do, there's just one thing I want to emphasize that before we implemented this platform, we had to teach our students to learn coding in Python or Scratch and then show them how to do encryption using coding, which was very helpful, especially learning programming or coding. But we realized that some of the students struggle with the coding itself rather than focusing on the underlying core concepts of cryptography. So this elevated some of the challenges that students had earlier by focusing on the core concepts. And this is another example where students type a message, it generates a corresponding Morse code. It also can play the sound, and here it shows some historical background about Morse code. We also cover some modern cryptography, like public key RSA, one-way functions, encryption, and how it is different from hashing. And this is an example of RSA demonstration, public key. So also again, how's the concept? What is the concept? Here we have animation. Classical example, we have a sender, receiver, Alice and Pop, and how like they encrypt message and how the receiver Pop decrypt the received message and how to use public and private key. Also here we have another example on how to generate by yourself the keys, what is the underlying math, the formulas and the equations used to generate the public and private keys used for encryption and decryption. This is also another example of a test. It's like shown in between modules or within learning modules, and students answer, and it show you the score and also provide you explanation why your answer was right and or why it was the wrong answer. So we notice that providing immediate feedback to the students, especially in between lessons or within the lessons is very helpful to retain information. Um, Here we, after covering classical encryption decryption techniques, we also cover topic which is a very important topic, quantum computing. And here we explain to our students examples about what is bits and what is qubits and what are different terminologies like superposition, quantum algorithms, Shor algorithm, and how these are like technology, which is quantum computing, can impact current encryption decryption technique. As you know that most of encryption algorithms, especially public key algorithms like RSA, the main cornerstone of these algorithms is that it takes very, very long time to decrypt a message. So the strengths of the algorithm rely on the concept that it's very computational expensive and takes a lot of time to break a message. A message could be your social security number, your credit card number, your private information, a message sent between you and your friends, health records, any sensitive information. But the problem is with quantum computers, uh, it can break it in a couple of seconds. So whatever, like in a classical computer, a process can take like weeks or months or maybe years. A quantum computer can do it in a few seconds. So the implication of this that we want our students to learn about quantum computers, how they impact current algorithms, and how to make more stronger encryption techniques that are not vulnerable to quantum computers. And this is an example of a simulator that illustrates what I was just talking to you about. So here, like for example, what a process that might take several billion years for a classical computer can just be done in few hours. So this simulation simulate an attack on an RSA algorithm. So this like show our students the impact of quantum computers. Currently, quantum computers can do it, but they are not reliable. But once they are reliable, all our systems that we use, banking systems, health, hospitals, everything are vulnerable and can be attacked in a couple of hours. Um, Another component that was very engaging for our students, especially in the platform, is the mystery game. So students here act as investigators solving a fictional crime using cryptography techniques. So there is a villain, and he left like encrypted messages, and the students need to decrypt this message and figure out who is a killer or a villain guy, the bad guy, before he or she will commit the next crime. So this is really nice activity and use game-based elements. Now we use CryptoLearn in multiple education environments. Especially we use it in our outreach activities at VMI, my university. In the outreach, we go to middle and high school students in their schools, or we invite them to VMI. We conduct sometimes workshops, and also we sometimes invite them to like the regional library. We talk to them about cybersecurity in general, cryptography, quantum computing, and then we use CryptoLearn within our outreach activities. it's observations that we notice indicate that interactive exercises, game-based learning, and gamification really improved engagement and curiosity. We also found that when students focus on the core concepts of cryptography through the platform, it helps them understand better the concepts of cryptography. Earlier, students have to build the code using Python or Scratch. Especially for middle school students, it was really hard and they were struggling, especially who have no background in coding. And instead of focusing on cryptography, they were struggling with coding. So CryptoLearn was helpful in this part. And it also can be utilized in blended learning mode. So students can go online, it's available online. They can learn anytime, use the platform anytime. It doesn't have to be in class physically. So it was really helpful. In general, the students' feedback was positive, and it's a continuous project, so we are adding new features over time. Our long-term vision is to create like a scalable education environment, support in general cybersecurity education and cryptography and post-quantum cryptography. More lessons, modules will be added over time and more games over time. And we will be collecting also students' feedback and hopefully will make the platform better over the next years. One thing we're gonna have to focus on in the future is conducting a structured learning study and also try to do survey. Another feature is like adding analytics and teacher dashboard. So the analytics part is really helpful because it will allow us collect data about how the students interact with the platform, how much hours they spend on each module, which quizzes they struggle with, which parts they are doing well in. So this also will add really nice information in addition to the surveys and assessment. This work was supported by the Commonwealth Cyber Initiative grant. And thank you for listening and joining my session. I will be more than happy to answer your questions.
Thank you so much.